Starting with our land acknowledgement. The Crow Canyon Archaeological Center acknowledges the Pueblo, Ute, Paiute, Dene, and Hickory Apache people whose traditional homelands this institution sits. Our mission-related work would not be possible without Indigenous people in the past, present, and future. We respectfully recognize and honor ancestral descendant Indigenous communities for their contributions to all of humankind. Crow Canyon is grateful to all Indigenous people and supports the preservation and protection of cultural traditions, ancestral connections, and sacred lands. Our mission here at Crow Canyon is to empower present and future generations by making the human past accessible and relevant throughout the archaeological research, experimental education, and American Indian knowledge. You can visit us at crowcanyon.org for more information. I just want to reiterate that we are a nonprofit institution and we couldn't do it without the donations and participation of folks like you that are joining us on our webinar today. So we very much appreciate it. Just a quick note on Zoom, if you could put any questions throughout any time of the presentation into the Q&A at the bottom of your screen. The chat kind of, sometimes questions can get lost and people do use that to actually chat with their friends. So the Q&A is the place for that. If you're having some issues with Zoom, just head over to crowcanyon.org on our Facebook page, and we will record this as well for our YouTube channel that you can subscribe to look at some past and future webinars as well. Upcoming webinars, we've got next week, Baker Marrow is talking to us about gardens in the sand, historic early landscapes in the Southwest. And then the following week, we've got Dr. Kelly Hayes-Gilpin giving us a talk on duck pots in Brooklyn and rediscovering Hunters Point Chacoan community. Quick bio on Dr. Lynch, who's joining us today. She is an anthropological archaeologist. Her research uses 3D visualization, morphometric analysis, and Native American narratives to understand how ancient peoples created social landscapes, tethering socio-cultural reproduction of knowledge to ancient canyon landscapes in the high plains of Colorado and New Mexico. She was awarded a Fulbright Teaching and Research Scholarship for 2023 and 2024, which she will continue her work in community-based engaged science and resilience post-Hurricane Dorian. So that's a multidisciplinary project funded by the Natural Infrastructure in the Caribbean in Grand Bahama, which sounds beautiful. I'm a little jealous. Dr. Lynch is completing her postdoctoral research with the Hell Gap National Historic Landmark, and just informed me that she took a post as an assistant professor of applied archaeology at Eastern New Mexico University. So without any further ado, I will stop my screen share and let Dr. Lynch take the reins.
Okay, so how are we doing?
You're coming through clear.
Awesome. Well, thank you very much for that wonderful introduction. And I'd like to also thank all of the organizers at Crow Canyon for inviting me to present some of my more recent research on the Bedrock Brownstone features that are found in southeastern Colorado. And this is a view of one of the main intersective landscapes that I work in during the summertime. So the bulk of this talk, though, is going to be about how archaeologists develop interpretations of the past, in particular, how material culture and social identity are interconnected not only with each other, but also with the environment in which we find that material culture. There's a dynamic between that material culture, how we reproduce our knowledge systems, and the spaces in which people live, that's often borne out in a ritual use of space. But that ritual use of space is a very tricky thing to pick out of an archaeological record, especially one which is very fragmentary. So with that in mind, I want to talk about a couple of really critical themes today, and hopefully this will be some good take-home information for everybody. Predominantly, and first and foremost, I kind of want to present a dialogue or open a dialogue on what we consider to be Brownstone tools as part of a broader technological suite of instruments. Brownstone's often left outside of things, as I'll talk about in a little bit, but I want us to consider Brownstone in particular as part of the overall toolkit that people actually use to get through their lives. We're going to focus particularly on Bedrock Brownstone features because of most of that toolkit, the Brownstone toolkit, these are the most understudied across the United States and the world. I also want to talk about how we actually understand Bedrock Brownstone tools. How do we identify them? How do we describe them? And how do we study them so that everybody can get a good handle on what the tools are that we use as archaeologists to interpret it, because I think that's very important. We're going to talk primarily about Brownstone tools in North America because that's where I work. And we're going to focus predominantly on the plains of Colorado. And so, but we're going to try to tie it all in together with the broader ethnographic and ethnoarchaeological materials that are out there. I want to explore some theories and methods that are used generically. And then I want to talk specifically about the cases that I know about in Colorado so that we can have some specific case studies. Brownstone tools are often thought of as this really straightforward tool group. They're portable monos and metates. Everybody knows them. We ignore them habitually on our archaeological sites. We construct fences out of them. We make things out of them in our homes. They're not the sexiest toolkits out there. They're not projectile points. They are the utilitarian everyday items that we run into. And so therefore they're often ignored. But Catherine Bartlett in 1933 asked us to actually pay more attention to these Brownstone tools, particularly those that we're using for food processing, because they're the foundation of human food systems. Without them, we're not going to be eating these really finely processed food sources. Jenny Adams continued this discussion and starting in the 1990s started pointing out that, yeah, these are important as our food system, as part of our food technology, but they're also important in a broader context. So we really want to start paying more attention to them. Not a lot of people have heeded this advice, but nonetheless, it's important advice. Brownstone tools, though, are more than just those food processing tools. They also include things such as palettes that were used to process paints and pigments and other types of things. They include abraders, such as this abrader over here in the corner from Hellgap site. These are used for many different types of tool making processes. They include mortars for different types of grinding activities. They include hammerstones that are used for a variety of activities, and they include a plethora of polished stone tools. So the category is quite broad, it's quite complex. There's a couple of tools that I would like to leave you with here. The key reference book, if you're interested in and you need to know more about Brownstone tools, is Jenny Adams' Pivotal Brownstone Manual. It's available on Amazon. It's a great book, and it's one that most everyone who's working in Brownstone actually uses. However, I also want to recommend Woodbury's Peabody report from 1954, which deals specifically with Hopi toolkits and archaeological sites. I feel like this is one of the critical classificatory systems that is out there, and I think everybody should give it a wing. Other resources include the Association for the Brownstone Tool Research. Yes, there is an international group out there that is dedicated to the study of Brownstone tools. We work across the world, and our meetings are in some of the more interesting places of the world as well. So if you need one more convincer that this is important, Cynthia Irwin-Williams and Henry Irwin pointed out in their work at Magic Mountain that Brownstone tools have to be studied. They're quite diagnostic, and they're very important to include in any conversation in our stone tool assemblages. So I have to say that's one of the reasons why it's important for us to get to know this. But what about Bedrock Brownstone? Well, Bedrock Brownstone features are something a little different, and even folks doing brownstone studies don't often like to delve into bedrock brownstone. This is an image that's taken from Chinchera Cave in southeastern Colorado. It's something that I'll be talking about a little bit later. You can see the depressions along the surface. The site has been explored since the 1950s and recorded and excavated quite often, and yet these surfaces have never really been studied or analyzed until very recently. And I'll have a report coming up. And this is kind of the situation generally where we find these types of things. We just sort of like note that they're there, and then we quietly move on to other aspects of the archaeology. One of the things that I'm doing in Colorado is trying to actually break this apart and understand this pattern. And I said Colorado, but I really implying also northeastern New Mexico and the western panhandles of Oklahoma and Texas. So working with bedrock brownstone features is facilitated by consultation with descendant communities. But in southeastern Colorado, these features have been abandoned since about the 15th century, perhaps even earlier. The situation is made more challenging because the use patterns that we're seeing, and this is a stylized graphic here, which shows a gray area, which is an abandoned bedrock surface, and then individuals creating new surfaces. And so these types of patterns change not only within the life use of that surface, but also in time through weathering and other processes. So it's a very challenging to try to figure out what is going on any given site. We need to know a lot of different things. We're trying to figure out how are these groundstone surfaces used? How many people could have processed things there? Were they processing food or other types of materials? How do we know when one surface is abandoned and why, and another surface is started? These situations are going to be highly localized, and what's going on in California might be different from what's going on in southeastern Colorado, because people are making different choices depending on their localized needs. In order to get at this, we use a simplified lithic analysis process really adapted very loosely from Odell's 2004 lithic analysis process. We first have to identify what these surfaces are and make sure that they're human, not natural. We also need to be able to identify and measure every single surface and bit of a boulder on which we find these things, including the rock shelter or the open air in which it is located. Once we start gathering those data, the measurement data and the descriptive data of a site, we can actually start to describe the patterns that we're seeing and then begin to form an interpretation of how those patterns parse out on the site and then within the region. And it's more than an interpretation, it really becomes some quite heavy duty analysis once we start putting in and plugging in all the numbers. Once we've done that, we can start actually integrating what we're seeing on these sites with the local tool assemblages, as the Irwins recommended that we do, and then begin broader regional comparisons, which I'm going to show you a little bit about that in today's talk. Before we get there, I want to talk a little bit about theoretical approaches, because for as many archaeologists working in this field, there are that many theoretical approaches, and some of us use all of them. These are the ones that are most important to my work, and so these are the ones that I kind of want to talk a little bit about and make sure we're all on the same page. So descriptive approaches are really documenting the patterns as I've just described, and these are really getting a handle on localized patterns that we're finding in the archaeological record. Ethnoarchaeological approaches take place within living communities that are still actually working with that bedrock groundstone surface. I'll show you a couple later on. To better understand how humans are actually using things, those of us working in areas that no longer have descendant communities actively using them rely heavily on these ethnoarchaeological processes and studies. Other approaches include adaptive modeling of food consumption and potential landscape movement to try to access resources and where these particular bedrock groundstone features might be found. These are really strongly parsed out in California in the Great Basin, but also in some of the early Natufian cultures that are found in the Levant. So that approach applies there, but it's a very interesting approach that hasn't been applied in southeastern Colorado successfully. Gender studies and trying to figure out how women and female spaces and power systems show up in the use of bedrock brownstone, particularly as it is interwoven with the landscape and other social cultural norms, is very important in California. But some of this really great studies have been done by Dr. Clausen out in the Eastern United States, where she's looking at the ritual space of creating female identity. So if you're interested in more of those sources, there'll be time for you to ask me about them a little bit later. Other really interesting approaches ask us to really consider how these types of features form part of the symbolic life of a community that was using them. How are the features symbolically part of the other world or the ancestral world? And this is done in Sweden and in the Levant, but we also do a little bit on the southern high plains. And finally, we look at those of us that are interested in social reproductive systems, in particular, how knowledge is created and reproduced generation to generation, actually like bedrock brownstone surfaces because they're stationary. And once you start to get a handle on all of the methodological approaches that are out there, and you can start building up some large data sets, you can really get a handle on how people use these spaces. In order to get at social reproduction, though, I have to say the most important thing is to get your hand on Native American oral traditions and descendant communities, because that's where you really build a solid understanding and interpretation of what social production at these sites entailed. There are a lot of methodological approaches out there for brownstone, and brownstone specialists use every single one of them as they apply to the sites that we're working on. Morphometric analysis is the basic stepping stone for every single brownstone research paradigm that I know of, portable and permanent. These include gathering the very foundational measurements of a length, a width, and a depth. How they're done varies depending on the region, but thanks to Jenny Adams' book, most of us are pretty much doing the exact same thing, and I'm going to show you an example of that. Using these basic length, width, and depth measurements, we can actually formulate some very complicated ideas of shape and of size, and we can do large comparisons, and I'm going to show you that in a little bit. We also do residue analysis. Anything that we can sample for on that surface, we sample. We look for pollen if we think we can get it. We look for phytoliths, lipids. Even there was a study just recent about trying to grasp DNA evidence, plant DNA evidence, and animal DNA evidence out of the tissues of some porous materials. And I believe it was in Southern Europe somewhere. We also have to get a handle on what the design process is of those particular use surfaces. So we pay particular attention to any retouching that was done on the surface. Perhaps a surface became so smooth it was unusable, so it was repacked. But you have to be very careful in bedrock brownstone surfaces that we're not picking up weathering processes as opposed to actual human repacking. We look at things like sheen across the surface to see how materials might have been moved or how weathering is affecting the surfaces. So there's a lot of things that we want to understand in terms of how those surfaces were actually designed and used throughout their lifespan. Whether that lifespan included the one generation human or multiple generations of human, it's very important for us to try to get a handle on that. 3D analysis and virtual reality are the newest tools that we have in our handbook. I'm going to show you a lot of that because that's what I use predominantly now. This allows us to really do some comprehensive understanding of the shapes and how those parse out, but it also helps us to bring these shapes to the general public and to other scientists so that we can develop a very highly replicable system of study. It's really good. Bedrock brownstone surfaces are found throughout the world. As I've said, Australia, Europe, and Africa, the Levant, China, they're found everywhere. They're only really studied in a few specific areas. The most famous right now is an article that was just written on some Australian groundstone. In North America, bedrock groundstone surfaces are found throughout North America. They're most highly documented both ethnographically and archaeologically in California and the Great Basin area of the United States. However, we also have some really nice studies of these features in the southwestern part of the United States, as well as northern Mexico. The Chihuahua and the plains are beginning to become much more well documented. We have them in western Texas as well. Arkansas and part of the Mississippi area in here have some documentation. It's not very strong, but it's starting to at least be recommended in CRM reports, cultural resource management reports. But the second most highly documented area would be in the eastern United States. And this work is a lot older than some of these other regions. So we have some really good handle on how they're using these types of features. And we understand that, yes, a lot of the features are being used as female retreat areas where women go to develop their social identity as part of the community, and they develop their tools at the same time. So we're going to focus though on a small hydrological basin. It's actually rather large in southeastern Colorado, and we're located pretty close to New Mexico. The actual extent of this particular cultural expression of bedrock brownstone is probably much larger than what we're focusing on. So I've actually included northern Mexico, Texas, and Oklahoma as well as other regions outside of where I'm currently studying in Colorado. But you can see it's a very dynamic canyon system. The one site along the Chihuahua is right here, and it falls into the Purgatory. All of these drain into the Arkansas River. So it's a very dynamic, lush area, even during drought seasons. In 2020, I asked and received from the Colorado SHPO, or State Historic Preservation Office, all of the sites within Colorado that had something that could be termed a bedrock brownstone surface. And there's a lot of terminology problems in this region, so we searched every possible term that could possibly ever designate a site. And we ended up with 450 plus sites. I combed through every single one of those and narrowed it down to a little bit closer to 450 sites. Here is a plot of where all those sites parse out. And you can see in Colorado in particular, they really follow tightly those drainage systems, but we also have a really dense concentration here along the Purgatory and here very close to Fort Carson. And that's because these are military reserves and they have a cultural resource management mandate. And so they do a lot of recording. And so this is a little bit of a skew of what we can expect to find out there. I suspect if we were doing as strong a systematic survey and cultural resource management for the entirety of the state and northern Mexico, New Mexico, we would actually see this same sort of dense pattern. So you can see we really are just touching the surface of what's out there in terms of bedrock brownstone surfaces. So today I want to talk specifically about 3 sites. And these 3 sites are sites that I've been at. I've actually documented the sites myself. I'm not using tertiary or secondary data. And so I can tell you what's on there. And if you've got detailed questions, we can handle those. The first site we're going to visit is the J.E. Canyon Ranch sites. This is located on the Chihuahua Creek drainage area, which drains north into the Purgatory. The site is pretty complex, and it's actually a multi-site system along this drainage area. Once we're done with that, I'm going to pop over and north a little bit to Matata Cave, which is located on the Pinyon Canyon Maneuver site, which is how I first became introduced to that site. And finally, we're going to pop down here close to Trinidad, Colorado to the Chinchera site. This site is the one that we opened up the talk with today, which hasn't really been recorded. The bedrock brownstone hasn't been recorded. There's a lot of excavation out the site, but we just don't have a handle on the bedrock brownstone surfaces. Okay, so let's get started with J.E. Canyon. This site was first brought to my attention by Larry Lohendorf, who was my boss at the time. He and the Colorado Rock Art Society were out Rock Art Association were out doing survey in this region, and they asked me to tag along, and I did. And we started seeing and documenting the Bedrock Brownstone sites that were found on this particular ranch. And so we had permission and also with the approval of my dissertation advisor, Mary Lou Larson, we were able to go out and actually document all of these sites. So I did a systematic survey with some great volunteers starting from one end of this canyon. I don't know if you can see my cursor, all the way up the canyon and up this steep slope into and past this permanent spring up to where the water drainage starts. We have sites all the way through this area. Most of them are lithic scatters. There's a historic farmstead here, but as you walk along this landscape, which can be done easily in a day, you find more scatters of tools, and then you find couple of more tool scatters, and you find bedrock brownstone along this area. So these rim sites here actually face this broad, expansive canyon system, whereas the sites along this inner part of this canyon actually are very, very secluded. And it's these sites that we suspect it's these inner sites that we suspect might actually be female retreat sites. So when we're looking at what bedrock brownstone tool search looks like in this region, we're going to start with what I call the cat site. I don't know if you can see the outline of the cat in this rock. It has actually another nickname, official nickname, but I feel like the cat site is best for us. Within the rock shelter, there's over 20 bedrock brownstone surfaces. You can't really see them here, but you can see that a historic dry laid wall overshadows them. It's pretty much what we're going to find in this region, though. It's a deep recessed rock shelter with a roof fall boulder that's been actually that has been carved out, or that basins have been formed within and on that roof fall boulder. On this site, as in most of the sites that I'm going to talk about, there's rock art nearby. So this is that rock shelter that I showed you, and it overlooks a very large, complex rock art panel. The site also controls a commanding view of the Chihuahua Plateau or the Chihuahua floodplain down below. And so it's both sheltered and it's open air, which is kind of cool. You can see everything, but you're highly sheltered, and really people can't see a lot of you. I'm standing on the ridge right above that site, and you can see there's this cap rock that's broken off and is sort of entrenched in the soil right there. And it's actually blocking some perspective of that shelter, because this is the shelter on this side. Looks a little bit more like a snapping turtle from this angle than a cat from the other angle. So it's very secluded, but it's also very open to the environment, which is important, I think, but we haven't really teased out all of the dynamics. Before I leave this particular area, I want to point out that along the rim that I'm standing to capture this photograph, we have 3 open air rock art, brownstone sites that are kind of hard to pinpoint, but I'm going to show you a picture of what one looks like in just a second. We don't really know what they're doing there, but they are found in open air. In fact, of the 450 plus sites in this region, only 27 of them are found within a rock shelter. The rest of them are in some form of an open air site. So it's kind of interesting. Okay, so one of the sites, remember I told you that up that canyon, we found a site that we think might be a female retreat area. Well, this is what that looks like. Here's us recording, or volunteers recording this site. We're using very manual methods. We're using pen and paper, measuring tools, a compass, measuring tapes. We document the entire rock shelter using these tools. We went back 3 or 4 times to actually ground truth in different light all of our work. So it's a very time and labor intensive process to do it this way, which might be one of the reasons why folks don't do so much of it. Yes, there is a trench in the back here that has been dug several times, probably by I'm not sure they were archaeologists or whether they were others kind of just trying to see what's out there. There is a rock art panel that spans the entire back of this shelter, as well as a very complex tool groove panel right behind this feature where these guys are working. We collected pollen samples from these surfaces that we can analyze to take a look at what is going on at that particular site. The site that's furthest away, when I pointed that out on the map, it seems like it's right there on the edge of that precipice, about ready to drop into the canyon below. That's this site. It also happens to be the site with the largest number of bedrock brownstone surfaces. So you can see here, there's over 68 brownstone surfaces on this site. It's not as sheltered as some of the others, but it still counts as a sheltered rock art and groundstone site. The rock art is packed directly on the groundstones, which is also something that's kind of unique. Or so we thought at the time, because we weren't finding any others that were overpacked. However, future studies and what I'm going to tell you is going to tell you that this seems to be a very common practice. What it means, we're not really sure. This is the view from that site. Again, it's the Chihuahua floodplain, and you can see it's a really expansive view. The only way you're going to find yourself here at this site is if you actually know where it is. It's very well hidden from on top, and it's almost impossible to access from the floodplain below. This is one of those open air structures. So you can see it's a 360-degree view of the universe. There's no shelter at all. You can see the polished surface areas here. These are very difficult to study, primarily because one of the things that we're concerned about is natural weathering. And so I oftentimes will take these particular sites and I will put them on a to be analyzed when we have more information pile. But I do document them as we go, and we do have 3D photogrammetry of them. And so we just need time to study them. So when I talk about those basic measurements, here's an idea of what I'm talking about. We take the measurement in centimeters from the longest axis and from the shortest axis. So we want to get the longest point and the widest point. We also flip it on its side and we take the deepest point of that surface. Using these, we can develop additional variables such as the parameter, or how long it takes to get around the side of that. We can also look at the surface area, and then we can develop additional variables that tell us what that shape is and how far off of a circle does it actually vary and deviate. These things actually allow us to compare across broader regions, which is kind of cool. I went back out to these sites after we did our preliminary data collection, and I performed photogrammetry, which is taking stereo overlapping photographs and using calibrated targets. And then we went back in the lab and we reconstructed these features in the lab using Metashape. At the time, it was Agisoft software. So from that, we can actually develop a topographical map and digital elevation maps so that we can get a handle on how grinders might have been using these surfaces. We can then actually cut these things up, turn them on their side, and instead of guessing at what the depths might be, depth is one of those things that's the hardest for everybody to measure. We can actually flip it on its side and get solid mathematical measurements of depth. And not only that, but we can see, as you can see clearly from this picture, one side is steeper than the other. And so we can see that its depth doesn't mean that it's formed like a cone. Depth means that there's stuff going on all along that surface area. In particular, we suspect that the grinder was sitting on this angle using this longer platform to actually grind, and using this shorter platform for something else, perhaps pounding and or capturing and moving it back in the basin. These are all working hypotheses as we move on. Then I took all of those metric data that we gathered and I compared them to California, which we had 3 really critical sites that had been ground truths with a descendant community had gone out and said, here's what we're processing on these sites. So I thought, well, how does that look across the plains? How does that compare to the plains? And so the important thing here for you to kind of look at is that this top box is always going to be the J.E. Canyon Ranch sample, and the bottom 3 are going to be 3 different sites from California. One is in Northern California, and the latter 2 are going to be in Southern California. So as you can see, the depth for the J. Canyon is very short and very, we don't have really deep deep mortars out there compared with the California. And I can tell you right now, the bulk of these California ones are all circular mortars. And you can tell they're being used quite a lot. I think some of them are even around 25 centimeters deep. So they're pretty deep mortars. Whereas in the Chihuahua, they're usually pretty shallow, but they're not ephemeral. They're just not as deep as California. When you're looking at measurements for the parameter or just as a model of size, you can see that the J.E. Canyon sample really is closer to this particular Southern California sample, and it doesn't really resemble much that's going on in the other two California samples. Well, we know they're grinding acorn and pinyon because that's what the consultants told them when they were on site. We know that they're probably not processing acorn, at least not really good quality acorns in the Southern Plains. They're more likely processing amaranth and pinyon and perhaps juniper and maybe the gamble oak that's out there, as well as other resources that they found interesting, perhaps even timber processing. In this, we're looking at four different shape variables. Now, it's complicated on how we got here, but let's just say these are all deviations from a circle. And when we're looking at the California samples, they have these spikes that are showing you that that's a perfect circle. So these are indicative of a mortar and a pestle process. J.E. Canyon, which again is the top box, does not look anything like any of these other shapes. So it's a good bet that although they are probably doing some minimal pounding, they're not really pounding, they're doing grinding. And they're grinding resources that are being used differently than they are in California. Okay, enough of J.E. Canyon, let's move on to Matata Cave. So Matata Cave is located on the Penny. This shelter has been recorded heavily, both for the rock art as well as for the groundstone has also been recorded, although we did a much more thorough groundstone capture this time around. In this particular sample, we had 1 day to record so that we split into two teams. One team did manual recording, just like I described for J.E. Canyon, and the other team did photogrammetric recording so that we could get the capture done in 1 day. There were specialists. The photogrammetric capture folks were specialists. As you can see, this is a very deep rock shelter. I'm deep inside this rock shelter. There's a lot of shade, and it has a captivating view of another drainage system and all the ridges that are surrounding it. The image that I'm showing you right now is an orthographic model, orthographic image that was constructed based on the model that we created in the lab. It's a much more rich drawing than some of the field drawings that we would get, or than even a photograph. In fact, we wouldn't be able to get a photograph this comprehensive because the ceiling wouldn't allow us to back out enough to do that. So the only way to really get this nice flat model of the surface area is through photogrammetry, close range photogrammetry. So if you can see, the shapes are all across this main feature area. I'm hopeful that you can see the rock art that crisscrosses across this particular set of groundstone surfaces. We also have some groundstone surfaces lower on here that are actually over grinding on a netting pecked surface. And then finally, we have a lot of folks who visited this site throughout time, and they've carved their initials, including a couple of guys who actually ended up registering for the draft in World War I. They actually came out here before they registered for the draft. I looked it up. One of the other things you can see from this orthographic model, and you'll see it also when I show you the 3D model later, is that there's this area that seems to have been shorn off right here. And indeed, there is a feature, this feature right here, which is sitting vertical to that original groundstone feature. And it is very clear that they were doing grinding at one point in time. And then because of the erosional processes underneath that particular ledge, this piece broke off and became a vertical rock or boulder. They no longer seem to be grinding on those surfaces after that. Instead, they began doing tool making these kind of oblong boat shapes. And we can tell that by looking at these DEMs and seeing, okay, well, we have these U shapes, that these actual basin shapes that were kind of clustered together. And then we have these overcutting and superimposition going on for these tool grooves. And you can kind of sort of follow that through. Although I will have to admit that these 3 DEMs represent 3 different interpretations and possible hypotheses for how that process occurred. So we can actually speculate a little bit on what's going on or interpret. Chinchera Cave is the last shelter. It's kind of taking us a little full circle before we change directions a little bit. Chinchera Cave, located near Trinidad, Colorado, is a large rock shelter. Again, it's been excavated quite thoroughly off and on for more than 60 years. Where this student is sitting is the bedrock panel that we were recording. In this instance, we had less than a day to get out here and record everything, including a complete landscape virtual reality tour. So instead of spending a lot of time doing the manual mapping, and I do not recommend this, we actually just used photogrammetric data and data capture in order to understand that bedrock brownstone surface. Behind her is a large rock art panel that spans this entire wall, and it also spans the wall that's to her right shoulder, and also this little area right here. So it's a complete, almost amphitheater of rock art that overshadows this particular brownstone. So using 3D morphometric, or using those data capture out in the field, I was able to bring it in and actually analyze those bedrock brownstone features. There's 4 on site. The largest one is this main one that I showed you in that black and white photo at the beginning of this talk. The other cool thing that we can do, besides understanding what these features are and how they're related to each other, and you can see superpositioning, is we can actually present this model to whatever scientists or researchers or general public are interested in them. And you have the opportunity to engage directly in our field research and see, okay, well, she's relying totally on this camera capture. Well, is this a good camera capture? Is there a lot of error underlining it? What all can we do with this model? Can I have a copy of that model and put it into my VR machine? And the answer to all those questions is yes. This is a very interactive type of field research method that we're just sort of tapping into for our work. So let me summarize everything that's going on in this region so far. There's 450 sites overall in this southeastern Colorado viewshed. We only are looking at 3 of those sites. For those 3 sites, the bulk of the bedrock brownstone features are found in J.E. Canyon. Those also include the largest number of features, because features are any boulder that's separate that has grinding on it. However, we only have 7 sites in total, and recall that there's at least 27 sites that are in rock shelters. So that tells us there's a lot of recording that needs to be done. There's a total of 318 groundstone surfaces in this sample now that we can start comparing regionally, and those papers are going to be coming out over hopefully the next fall. But you can also see that Matata Cave has the largest single set of groundstone. Recall that at J.E. Canyon there were 63, that was the largest number, and Matata Cave beats that by far, hands down. At all of these sites, there's rock art, some intensive, some light. They all date from about 2,500 years ago to about 500 years ago. Some actually go a little bit more recent. And there's basins and grooves and cupules on every single site, except for Chinchera, which has no grooves. And that to me is a question for why. Why are there no tool grooves at Chinchera? There should be something going on there. Okay, so when we get to the end of the day, that's great, we've done a lot of recording, but now we need to start working out some interpretations and see how this tells us about life, the universe, and everything. So I predominantly follow a landscape perspective. That means that I assume and I try to show that bedrock brownstone features are part of a large dynamic system, human system of landscape use that includes all of their social knowledge, all of their ecological experiences, and it somehow parses out through the material culture, not just the stone, other lithic materials or their architecture, but it also parses out in this groundstone. These spaces represent a participatory and active learning environment where people are learning to grind at the same time as they're learning who they are as human beings, and they're in their cultural group. They're doing this by the presence of rock art, but also the presence of elders, by the presence of children, and by the presence of peers. And so it's a really dynamic environment. The archaeological material culture is a socialized landscape, if you will. And this means that basically this human social aspect is kind of colonizing that landscape and making it more part of the culture. Bedrock Brownstone features, that's BGS. Bedrock Brownstone features represent both daily practices because we know they're grinding regular food sources there, but it also incorporates this richer symbolic meaning. Now, I didn't just jump here and you're going to say, well, Elizabeth, that's all fine and good, but where's some of the evidence for these assumptions? And it's good that you asked that because now I can talk about grinding spaces in other areas of the world. So I rely heavily on oral traditions from anywhere that they're using groundstone or they have used groundstone, as well as ethnographic stories about groundstone and archaeological studies. So in California, we have a lot of these. In fact, I did a study on the narratives that are associated specifically with groundstone tools. And groundstone is, in fact, a very critical part of the identity and how you become a human being within your culture. And it's also sometimes a portal to your ancestral worlds. So groundstone has this very symbolic meaning, at least in California cultures. And of course, they're found near houses. You can see they're found in open air, but also look at this. They're building structures over those open air sites. So for those open air sites that we have in southeastern Colorado, could they possibly be building structures that no longer exist? Family is really critical when they're food grinding. It's not just one person droning away in the kitchen by his or herself. I bring in the Puebloan Southwest because these are constructed groundstone spaces. So while they are portable tools, they are being brought in and used to construct grinding workspaces within the village, within houses, within ceremonial structures. They also have a rich oral tradition for incorporating these types of features into the storytelling. And they have a very rich sand painting culture for talking about groundstone and how it works as part of the ancestral culture. So there's a lot going on in the Puebloan world, and I use that to help understand the notion of constructed spaces on the plains. However, we also have documentation in parts of Africa for how these types of features are used as agricultural grinding spaces within the village, how they are used as part of hunter-gatherer toolkits, where in this instance here, we have Hazda hunter-gatherers who are using and choosing the sites that they're camping in based on the presence of eroded bedrock brownstone or bedrocks that they can use to grind baobab root or other resources. So it's very critical. We have ethnographic or ethnoarchaeological studies in Nigeria that show that not only are these part of the community and everybody knows where they are and how they were used, even if they've been long abandoned, but they're also retooled through time if they are important to that community. So we would expect to see, like as in this instance of this plan view, that we changed from using them to grind certain resources into what the consultant told the archaeologists at the time was to process ore and mineral ores. So these are very dynamic sites for many reasons. And this can create some typological problems, but we still need to try to get a handle on what the grinding motions might be that we're looking at, because that's going to help us back into what the behavioral patterns are of the grinders that are using those resources, as well as help us understand how the different surfaces may have changed across the same boulder, so we can understand, did practices change through time, or did grinders change through time, or are they doing different themes on these surfaces at different times of the year? So it helps us understand that, yes, it's more than just processing food, but it is but it is helping us understand the dynamic of the human behavior that's associated with the food processing. Finally, hopefully one day we're going to be able to actually do some of this cool stuff, which they do in the Southwest, is build these chronological sequences of groundstone through time, and then tie that into other types of things like pottery and steatite pipes and projectile points. So right now we can't do that in the Southern Plains in terms of the Bedrock Brownstone, but we will be attempting to do this type of chronology building, at least as far as we can with the structures that we have. What I've been able to do so far for chronology and integrating it into the cultural past is breaking up the sites that we have, so those 450 plus sites, into where they're located, either fully open air but near a rock shelter, and then totally within a rock shelter. And then look at what diagnostic tools and or carbon dates or anything that we have. What do we have that's dated, that's in close proximity to these tools, and how has it changed through time? Or has it changed? I mean, what we do have from the SHPO database is that we do have Paleo-Indian starter points for some Bedrock Brownstone tool sites. They're both open air and open air near rock shelter. There's a gradual increase in the use of sites or these types of sites during the Archaic period. And then in the prehistoric period, there's a real explosion in the types of open air and rock shelter sites. This purple bar graphic, and I hope it's purple on your end, is actually stuff that we don't know anything about, so we can't really talk too much about it. However, within those rock shelters, we can see that we don't have a really early component. They're really dated to the Archaic, so that's 2,500, 3,000 years ago. And they increased to where they stopped being used somewhere around the prehistoric time period as well. But again, you can see that it's a very small sample size, and we need to have a better handle on how they're interacting with other tools on those sites. So I'd like to show you a little bit of the model and what we can also do. And it's kind of cool because this is that rock shelter that I was telling you about earlier. And as it loads, I'm going to bring that up. So this was developed by my partners, Tom Noble and Nephra Matthews of the BLM. This is that rock shelter that has that very large, this is Matata Cave. So you can see we can develop the entire rock shelter. We can look at it from all angles. And you've probably already noticed, yes, I've talked about this feature and I talked about this feature, but I didn't talk about any of the others. Yes, there's a lot of groundstone, but you can also get a handle on that erosional process that I was talking about for my hypothesis that this vertical slab actually used to be horizontal. You can see here, this is an active water spring that's kind of breaking up the rock underneath it. But I'm going to move around to the back and show you. You can see this cleaving right here. It's very clear. It was done a while back and it's since eroded and smoothed over. But there once was a rock that was attached here and it just broke away. So you can kind of get a good handle on what's going on. And some of my students really like to look at the outside of the rock shelter, but we don't have a lot of time today. I think you're going to be able to go directly to this model from this link in this PowerPoint. Hopefully you'll be able to access it if you have any questions about that. Okay, so where do we go from here? Well, we've got to go record at least those other 20 sites that we know about that are in rock shelters and get to the rest of those 400 sites and then start doing more survey. We have to really develop and keep working on our robust models that are taught, especially the morphometric models and our 3D models. We have to understand the error that's associated with all of them. And I think in order to understand what's going on with those open air sites, we're going to have to do some ethnoarchaeology. Finally, as I've already started to do, we need to really include descendant communities that claim these areas in some way and start building and bringing bridges from these landscapes back into the descendant community so that we can better understand that human and human site dynamic and see what's important, but also reconnect descendant communities with their homelands, long lost homelands. 3 take-home points. Bedrock Brownstone features exist. They're real. They are real archaeology, and they are integral parts of past cultural systems. So we need to be recording them and doing our best to understand what they are. The best practice really includes manual and digital methods. So even though I did skip ahead on Chinchera, I am going to be going back out to Chinchera Cave and doing those hardcore models because really nothing surpasses those manual models. And finally, we need to develop and keep doing strong outreach programs that bring students, both high school students and college students, as well as just avocational archaeologists and general interest folks out into the field, either through 3D models or programs like this, or field schools. Here's a list of critical resources that I've used throughout my talk. I've included others within the talk, and I've also mentioned a few things that aren't listed there. So if there's anything that you really want to learn more about, maybe Nigerian ethnoarchaeology or whatever, please contact me, and I will make sure that you have access to those. This work was not done in a vacuum. I owe a thanks to so many people, but funding was provided by the University of Anthropology, and then a lot of tools for 3D visualization was provided through a partnership with the University of Wyoming 3D Visualization Center, but I also owe a lot of kudos and thanks to Eastern New Mexico for supporting this particular lecture opportunity. I also want to thank all of the volunteers and people who've helped throughout the years, but particularly Larry Lohendorf and Mark Owens, who sort of set me on this road, and the SHPO volunteers who worked through COVID to get me the data so that I could analyze those data. So, and again, the stewards of J.E. Canyon, Matata Cave, and Chinchera Cave have been so gracious with all of their time and with their insights. So I have to also throw kudos out to them. Thank you very much for your attention, and I hope that you have some questions and dialogue. And I'll leave you with this beautiful photograph of the purgatory as we hopefully chat.
Dr. Lynch, thank you so much. Very great presentation, very eye-opening, and just on a personal note as an educator here, moving forward, I'll be spending more time talking about groundstone and food processing in our educational modules. So thank you again. We do have a number of questions, so I'm just going to kind of start chronologically as to when they came through the chat. First one was from a Facebook viewer, just kind of asking if there was any studies that you're familiar with in southern New Mexico that show any similar patterns, or if you've just kind of been working in specific regions.
For southern New Mexico, really what we have are cultural resource management reports. They're being documented. I haven't actually gotten into the New Mexico system though. So I know there are a lot of bedrock brownstone features in this area, in this region, and they go all the way down into the northern, the New Mexico, the border with Mexico. I just don't think there's a whole lot of work being done on it. However, if you're interested, I will be happy to help do a current search just to make sure. But I think most of the stuff is either going to be in a cultural resource management, which will be highly inaccessible probably to most people, but I can help with that. Or it's just going to be like, oh, a rancher told me, kind of folks just out on tour, but they're there. So just not a lot of research on it.
Awesome, thank you. Have a question just about speaking maybe to some of the monos that have been associated with this. I know that in Puebloan culture, modern Puebloan culture, the processing of corn is the woman's responsibility. And this viewer is just kind of asking if the monos and the size might indicate whether anything about the gender of the user. If you could speak to that.
The general assumption, at least in southeastern Colorado, is that these are female spaces. So that's number one. That's a general assumption. I do know that in most cultures that do intensive grinding out in the landscape, the spaces are utilized in a more complex manner. It's not just females might be doing the grinding, but the site itself consists of elders looking over both males and females. Men are always associated in let me say, not say always, but in very, very, very many cultures, men are around and they're playing music and entertaining the women doing the work. That image that I showed you where the man was kind of sort of standing there, generally the flute players and the guys are there, they're playing music, they're checking out the girls, that kind of thing. But the spaces are very dynamic. The monos themselves wouldn't necessarily indicate whether or not it was female. We couldn't just assume because there's a mono there that it is actually a female site. but it is indicative. It will help us understand how those particular features are being used, right? Because we can then go back and try to fit the monos into those structures. Now, we can't do this. Well, the problem here is that most of the monos in southeastern Colorado are not directly associated with the tools that we're seeing with those nether stones. We really have those nether stones only. We will find monos maybe feet away or whatever, but in direct association, we don't often find those. So we haven't been able to design a really solid refit project, and that's going to be on the books to do. And I'm hoping I'll get a graduate student who really wants to do that, because that's a perfect graduate study in trying to refit what we have in from the toolkits, especially at Chinchera, where all those monos are housed in the Trinidad Archaeology Museum, but we know where the site is, so we could actually do some testing in the field. So, or do it virtually and open up a Unity program and kind of do this all within a 3D virtual reality program. So all of that's possible, but it's not been done yet.
Little nudge, nudge to any graduate students on the feed today. Okay, I think we've got time for a few more here. What does the roughness of the depression indicate? Are you seeing any different like grit styles or grit sizes in these spaces, maybe finer processing?
So yes, number one, across the region, it varies depending on which site we're looking at, right? But across the region, in every instance, we have very smooth surfaces, like extremely smooth. In others, we have those same smooth surfaces, but there is some retouch on the inside, that it's been repecked like regularly. And we're sure that they're being repecked. In some of the cases, we are able to see striations, so we can determine wear patterns from those striations. In terms of actually trying to infer how fine the processing was, like if they're grinding food resources, the way we do that in southeastern Colorado is we use that Puebloan model where we know we have grinders sitting side by side. And so they're processing to certain degrees on one workstation, and then they're moving to another, and they're gradually refining as they go. And we know they do this in California as well, because we have it ethnographically ground truth. So in southeastern Colorado, what we look for are indications that material is being moved between surfaces, and that's either being done because they're neighboring. And I don't know if you'll recall some of the images, but where we might have one style of a basin that's jutting up against another basin. So we can see that, okay, this is being processed lightly here, and then it's moving into this area and being processed even more finely. But one of the most important telltale signs, I think, is the sheen and polish between surfaces. So that indicates that there's a lot of abrasion going on between those work basins, and that's tying basins together. Now, mind you, these are all hypothetical scenarios that have yet to be really fully tested, but we're hoping to get consultants out into the field from descendant communities that can kind of help with that, but also to design some tests, again, using 3D modeling to kind of better understand that. And finally, getting microscopes out to the site to really understand those finer abrasions that are going on between and within the basins. So there's a lot of work still left to be done.
Great. We have one viewer asking, just as far as LiDAR is concerned, would LiDAR be a useful tool, or are these features too subtle?
I toyed with the idea of bringing an Artec Space Spider out there, which is a structured light scanner. So LiDAR is really, I think, not going to pick up what we're looking for, but at least not to the level of detail that photogrammetry will. But a structured light scanner might, right? And that would be bringing one of those laser scanners out there and trying to scan it. The problem is the amount of sunlight, and the changing sunlight situations. And so I do have an Artec space spider at my disposal. And it's one of the things that I was going to try to experiment with when we go back out to Chinchera Cave, is to look at the difference between the close range photogrammetry and the structured light scanner. I will tell you that I prefer photogrammetry for a couple of reasons. Number one, it's easy to capture these photographs if you have a decent digital camera, right? As long as you just follow some very simple rules, you can capture photographs, and it's very forgiving, the Metashape software. So you can do a lot, even if you have high error in your photographs. And two, even with error, you can get some really incredible millimeter analyses going on there. So also, I can give you the data set and you can play with it. And it's just maybe 20 or 30 camera settings and photographs. So you can actually get that raw data set and play with it yourself, in addition to the camera models that I have. And oftentimes as a researcher, if I'm going to redo somebody's model, I don't want their model. I want their data set. So I want their raw data capture so I can actually go in and explore that myself. And I do have a McNair student right now who's working on looking at some on-the-fly photographs, and actually designed photograph projects. And it's kind of cool, some of the results she's coming up with, but it really is, and she's an undergrad, so graduates are welcome on any of these projects as well. So I think photogrammetry is a little bit more forgiving, and I think I still prefer it, even though I do explore other types of scanning technology. I really do prefer close range photogrammetry. It just seems to give me the best models, and the best data sets and the best underlying error reduction technologies. So I like to get my hands dirty and see what's underneath that model. I don't just want the pretty pictures.
Yeah, absolutely. Thank you. I think we have time for one more. I'm going to do my best to combine a couple here. So I have some talking about the rock art and the ritual nature of this. And there's also one about the pigments and the pecking. Do you have any theories or ideas about, what kinds of ancestors to current tribes are located in this area? Are they using different stylistic things with the rock art that kind of coincide with those spaces? If you could speak to that a little bit.
My best guess, I'm going to default to Roger Ecclehawk's notions that these ancestral lands are probably related. The ancestral peoples here, Pishipa groups and whatever, are probably more related to the Arikara descendant communities. But I don't know how old that's going to be, but I'm guessing that's pretty old. And so I am in contact with the Arikara as part of my regular research to try to get them out to these sites. And we're trying to arrange COVID threw a big wrench in that. So we haven't actually gotten onto these sites yet, but the goal is to get the Arikara representatives out here and then to build some models and get those back into the community centers where people can engage. The other groups that are more closely associated or really claiming these areas are the Comanche, the Apache and different Apachean speaking groups. The Diné probably were in this region at some point in time, but I'm not sure how actively they're claiming to be out here, but they have some similar things. So I use their storytelling a lot. And then the Southern Ute were in the area as well. So I'm sure there are other groups that are probably in this arena, but those are the groups that we're primarily working with to try to understand how these different areas might, especially given with the rock art and how they might tease out. I can tell you that the rock art at Chinchera is a real hodgepodge of different plains groups. There's a lot of Apachean rock art. There's a lot of different groups that are out there, and there's a lot of Southwestern pottery. I say a lot, and I'm saying that in relative size to other sites that I'm looking at. The stuff that we're looking at in the northern part or on J.E. Canyon and on Pinyon Canyon, those are either related to the cultures that precipitated the Pishipa groupings out there. So they're probably some form of early Pawnean groups, probably predate the Apachean groups in some ways. But, that's hard to say because folks are moving around a lot in that area due to colonization in different parts of the region and population movements. So I say my guess best is it's a highly dynamic setting. But we will eventually be able to tease out these cultural sequences the more people we get out on sites. And so we're working to do that. We're really working to increase our collaborations.
I love that. We are as well here at Crow Canyon. So
yeah.
Well, Dr. Lynch, thank you so much. That was an awesome presentation. And thank you to all of our viewers. And we want to respect your time, so we'll sign off here, but really appreciate you and hope to see you here in Crow Canyon in the future.
That's my goal. You're on the top of my list.
Okay, we'll see you soon.
Thank you very much.
All right, bye.